discuss how we classify and identify igneous rocks. Here's a nice photo. I think I showed it in my other Igneous Rocks lecture, and if you haven't seen that yet, go watch that lecture before you watch this one. But here we're actually looking at a bunch of basalt, a fresh lava flow. So, first off, we have rock-forming minerals. Not all the minerals that we've looked at will end up making up the common rocks that we see on the planet. There's really only a few that we see over and over and over and over again that make up just the rocks we go outside and find beneath our feet, or in general, just in the Earth's entire crust. So, again, I think I've shown this before, but I just want to hit this home again. Minerals make up rocks. So you can have a rock that's got a bunch of feldspar in it, and other feldspar in it, and a bunch of quartz, and that'll end up being a granite. So depending on what types of minerals and how much are in there, and what sizes they are, is how we'll classify igneous rocks. More on that in a second. But I just want to kind of point it out because it'll be important later. Some of these minerals are darker than some of these other minerals, and that actually helps us out quite a bit when we classify igneous rocks. You can actually identify igneous rocks based on their color, which is something we say don't really look too hard at with minerals, but when it comes to igneous rocks in general, color matters. So, again, we've talked about intrusive igneous rocks and extrusive igneous rocks. Intrusive rocks are the ones that will cool underground, and extrusive are the ones that will explode off the surface. Extrusive igneous rocks will cool quickly, and when that lava or magma cools off quickly, the minerals don't have time to really grow crystals very big, so you end up with a very fine-grained rock. Very fine-grained. Usually these rocks they can even be smooth, or they'll be kind of, I don't want to say sparkly, but more shimmery, shiny type rocks if you can actually see the crystals within them. Sometimes they'll even be kind of dull because these crystals are just so small, and we'll look at a lot of these. Intrusive igneous rocks are made from a magma that will cool down slowly, and it gives time for those minerals in the magma to start growing and getting big, because it just takes a really long time for this to cool down because it's nice and insulated by all the other rock that's around it. And so we'll call this coarse-grained, and we have specific names for the coarse-grained and the fine-grained. We call this aphanitic and this phaneritic. More on that later. Also, we could have something sort of an in-between where you get a magma that comes up and kind of stops. It'll cool off for a while, and then it'll get moving again and move on up, and then it'll cool off really quickly. So you'll kind of get a texture that's in between. Anyway, I'm getting ahead of myself. Just remember that there's some igneous rocks that cool off quickly here on the surface, and others that cool off slowly down underneath. And this affects the texture and how we classify these igneous rocks. So, this is important. Listen very closely. You will see this over and over again when we talk about classifying rocks. I will talk about texture and I will talk about composition over and over and over again. They'll mean slightly different things for the different rock types. So texture and composition is a little bit different with sedimentary rocks, with igneous rocks, with metamorphic rocks. But all of them are classified by their texture and composition. And basically, it's what's the mineralogy. What the composition is, what are the minerals that are making up this rock? And the texture is, what's the shape of those little pieces of minerals that are making up that rock. That's basically how we classify rocks. So the rest of this is basically what I talked about on the last size. We are concerned for texture. We're concerned with the crystal size, and it kind of tells us how the magma is cooled over time. Kind of tells us the history of that rock and whether it might have formed intrusively or extrusively. And again, chemical composition is basically the mineralogy of the magma. So with textures, we're talking about textures now. We can have fine-grained textures called aphanitic. This will be on the test. And we have coarse-grained textures called phaneritic. This will also be... oops, I should underline that one and box that one. My bad, whatever. So, what does that look like? Well, let's look at this one. So, here is a penny. It is not a mineral. Haha. And it's sitting on a piece of granite. And if you look closely at this granite, you will start to see little individual crystals of minerals. Now, they're not pretty crystals. They're kind of jagged, and there's some fractures in them. It's not like they're wonderful little crystals that you go buy at a rock shop or anything. But these crystals are different minerals, and there's about 3 different things I'm looking at in here. A lot of this kind of grayer stuff, that's smoky quartz. So we got quartz in there. This kind of lighter color stuff is mostly feldspars, and this really dark stuff is some kind of mafic mineral, a darker mineral like biotite or hornblende or augite. Yeah, you can see these different minerals, and we call this coarse-grained because I can see these things. These things are large. Look, they're almost as big. Some of them are almost as big as the penny. If I can see them, we call it coarse-grained or phaneritic. So granite is a phaneritic igneous rock. Aphanitic is where they are really fine-grained. You can't see any crystals unless you stick it under a microscope. So that's something like this piece of basalt here. And there's a bunch of holes in this basalt. We call that vesicular. It's got a bunch of holes in there from gases that used to be in there. But if you look closely at this, the solid pieces of the rock, it's just smooth. You can't see any crystals. And that's aphanitic. There are other textures. You don't need to memorize pegmatitic. But pegmatitic is basically where they're really big. The crystals get greater than 5 centimeters. I might show you a pegmatitic igneous rock or a piece of granite. But you get these huge, huge chunks of minerals. And honestly, some of these minerals you're looking at, the feldspars that we have, these big chunks of feldspars, they came off of pegmatite. Somebody beat up a big old piece of pegmatite granite to get those huge crystals. These things form when magma cools off really slowly, usually really deep in the earth. It doesn't get disturbed, and then these minerals can grow really, really big. Porphyritic, I do want you to memorize. Porphyritic is sort of a combination between aphanitic and phaneritic. It's a combination between fine-grained and coarse-grained. And basically that's how I mentioned in that little earlier volcanic slide where a magma will move up and it'll kind of pause for a little bit and large crystals will start to form in the magma called phenocrysts. So here's my, well, let's just say this is my chunk of magma, right? I'm just going to have it, my little hand-sized chunk of magma. It's slowed down, it's stopped moving, and little crystals start to grow out of it. Maybe they're little olivine crystals and they're nice and pretty and green. Pretend they're green. So I get a bunch of crystals that just start forming in there. And then something happens, an earthquake or something, or a fracture or whatever, and it moves to the surface. And poof, this thing gets to the surface. Maybe it comes out of the ground, maybe not. It just gets really close to the surface. And all this other stuff that's around these crystals will cool off quickly, and you'll end up with a fine-grained texture around all these crystals. So when you get this kind of half and half like this guy over here, we'll call it a porphyritic rock. And more on that later. Other textures we can get, which is like super fine-grained, is basically glassy. Something looks like a glass. Obsidian is the classic texture for this volcanic glass. So obsidian is a lava that cooled off really fast, really fast. Sometimes it'll erupt into water or to kind of cool off quickly. Other textures, and I don't need you to memorize this, but are you'll get vesicular texture, which basically means there's little vesicles in there. There's little holes from where the gas used to be. And we'll see this in scoria and pumice. And pumice is kind of a famous rock. Pumice can float on water usually, and a lot of people use pumice stones to kind of, scrape their skin off their feet or whatever. So that's all texture. What about the chemistry? Or rather, I could write mineralogy here too. What about the chemistry of igneous rocks? So it's all texture and composition. So this is the composition. Composition. I'm getting faster at that. So the composition that we really kind of care about has to do with how much SiO2, how much silica is in the rock. So don't read into this too much. If you're reading all this right now, stop it. Let me talk you through this. So there's there's more than three, but there's three types of textures compositions that I really want you to focus on. And these different compositions are basically how much silica is in the igneous rock. And what makes it really neat is the less silica there is in these rocks, and there's less silica as we go down. You see that? 65% silica, between 55 and 65, 45 and 55, less than 45% silica. As we go down, the color gets darker. So igneous rocks down here are usually darker, and igneous rocks here are usually lighter. And so we can use the color of an igneous rock to classify it. And so if they're really light colored, we'll call them felsic. If they're really kind of in the middle, you get kind of white colors and dark colors, we'll call it intermediate. A great rock for this is diorite. Diorite looks like a salt and pepper rock. And then this is the coarse grained version, the Aphanitic version is called diorite. The aphanitic version, or the fine-grained version, is called andesite. And these things will end up being kind of green or purple, kind of an in-between color between kind of a dark green or a dark black and kind of the lighter pink or whiter stuff up here. But it's all due to this silica. Because the minerals that are high in silica content, which is basically feldspar, and it's in the name. Felsic. Fel is for feldspar, sic is for silica. It's in the name. And then mafic is I forget what this split up is. Crucify me. I can't remember what the mafic stands for. But it's for the darker colored stuff, and we call those gabbro and basalt. I'm not going to worry about the ultramafic stuff. We're not even going to really look at those rocks. You might have sort of already looked at one without even realizing it. The samples we tend to use for olivine, the mineral olivine, is a rock that's made up of a whole bunch of tiny little olivine crystals. And that happens to be an ultramafic rock, and we'll call it dunite. Anyway, so let's talk about actually classifying these things and what it looks like. So let's actually talk about the rocks. So here's kind of a chart I like. We don't even have the terms on here. We could write the terms in. Light colored would be felsic. Medium color would be intermediate. Dark colored would be mafic. So up here on the top, we've got the compositions. And then down here on the side, we've got the textures. So coarse grained would be the Aphanitic. I'll just put a pH for Aphanitic, and fine grained for Aphanitic. So when an igneous rock is coarse grained, so you can see the crystals. And when it is light colored, you have granite. If it is coarse grained, so you can see those little crystal chunks, and it is kind of medium colored, you'll have a diorite. When you have a mafic rock or a really dark colored igneous rock and it is coarse grained and you can see those crystals, you'll have a gabbro. Now down here, around the fine grained stuff, or the aphanitic stuff, if it's light colored and really fine grained, you have a rhyolite. Same thing for intermediate, andesite, and then if it's dark colored and fine grained, it's basalt. We could also split these, we could put in another row right here if we wanted to, and I'll show you that later. And we could put in the porphyries, which is a rhyolite porphyry, and andesite porphyry, and a basalt porphyry. Basically, you take these fine-grained rocks and you put chunks of crystals into them, and we'll just call them porphyries. And then this is the ultramafic stuff down here. Don't ignore that. What I like about this image is, or this kind of table, is it shows what happens to the minerals in these rocks as you get more mafic. So over here we've got the percent of silica in them. Right? No. That's not right. I'm not sure what these percents are actually supposed to represent. Ignore that. Just ignore that. My brain's not doing it right now. Maybe it's the lack of coffee, whatever. But what I do like about this graph is it shows you what will happen to the abundances. Oh, sorry, these are the abundances of these minerals in these rocks. My bad. So it's the individual abundances of these minerals over here. Duh. Let's erase that. Erase that. I'm not going to re-record this whole video because of that mistake. So these are percentages of these minerals within these rocks. So a granite will have, 75%-ish feldspar. And then some quartz, and then some other darker minerals. This is iron and magnesium minerals here. So as you lose your silica content going to the right over here, as your feldspar starts to disappear and you see more and more iron and magnesium rocks in here and you see less and less quartz, you start to get into these other rock types, from granite to diorite to gabbro, or rhyolite to andesite to basalt. So I just kind of wanted to show you that there's, we create these nice little boxes, and nature doesn't really work that way. So if we all go out into the field somewhere, and let's say this class is done with, you guys are all great amateur geologists now, and we all go out in the field and we start talking about rocks. And we can actually, let's say we could actually take these rocks and measure the amount of minerals that are in them, and we could actually plot them out down here in these different places based upon the different abundance of minerals, and we can be like, oh, look, it plots out right here, therefore it's a diorite, or it's an andesite. In the real world, you will come, in the real world, you can't measure that though, right? You go out walking around, you pick up a rock, and you're kind of looking at the relative amount of minerals in that rock. So let's say we pick up a rock that ends up being, would plot out like right here. Well, then arguments start to occur, because some people will be like, oh, it's a diorite, and some people will be like, oh no, it's light enough, it's a granite. And you can see how there can be some gray area. So when I choose minerals on tests and things that quiz you on, they will be fully in these areas, and it will be obvious whether they're a diorite, a granite, or a gabbro, right? But in the real world, the nature doesn't like being put into boxes. This is something within science that doesn't get talked about enough. When in biology, when animals are classified, the whole kingdom, phylum, class, order, family, genus, species sort of thing, nature doesn't really work that way. That whole classification was basically designed so we could put things into boxes into museums, right, and try to make sense out of the world. But the world is a very organic place, and there are lots of ranges of how things can occur and how things exist. So sometimes it's hard to pick up something and state whether it's one thing or another, and it's okay to have those arguments and say, no, this is a diorite, no, this is a granite, because that's just how life is, or the world is. Anyway, I'm going to show you my That's kind of fuzzy looking. I don't know why that became so fuzzy looking. Well, hopefully you can still read it. So this is my table, and I'll upload the slides. The slides will look better than this. This is the table I've got that I want you guys to know. I will give this to you on a test. I will basically give you a blank table and say, fill in the igneous rock classification. I want you to be able to put mafic, and intermediate, and felsic, and aphanitic, and the porphyry, is it a porphyry, and phaneritic, and it doesn't matter which side they're on. It can be, this row or this column right here could be over here on the top, and vice versa. And you could flip this whole thing around if you wanted to. But I want you to know that a felsic aphanitic rock is a rhyolite, an intermediate aphanitic rock is an andesite, and a mafic aphanitic rock is a basalt. And if you don't know what these rocks look like, we'll look at them in the classroom, and also I have uploaded videos of all these rocks and what they look like. And there's little hints down here in these areas. Phaneritic is the crystals you can see, aphanitic is the crystals you can't see, and porphyry is both. Felsic, lighter color, intermediate is intermediate colored, and mafic is the darker colored. So things get darker as you go this way, and lighter as you go this way, and bigger chunks as you go down, and lighter chunks as you go up. Cool? Capiche? Cool? You must know this. You will learn this, and you will be happy, and you'll be a good geologist. However, we could expand on this if we wanted to. Those aren't the only igneous rocks, right? There is another texture of pegmatitic, and there's glassy, and vesicular, and even pyroclastic, which we didn't even talk about. And there's ultramafic stuff, not just mafic stuff, and there's other, and this can get bigger and bigger. But you can still see the primary spot that I want you to learn is this one. And this is the primarily the type of rocks you run into when you're out running around on volcanoes or whatever. And I mean, sometimes you find obsidian and pumice as well. But this central one is really what I want you to know. Just know that there exists things outside this table that I'm having you learn. And again, this is all dependent upon the amount of silica in the rock when we're talking about the composition, right? But I want you to understand that it's not that the silica is fully gone. We're going, as we go this way on this graph, we're getting more mafic. So gabbro and basalt down here. So this is your mafic stuff. And then this is your felsic stuff up here, and then your intermediate here. There's still a lot of silica in mafic rocks. It's still a very silicious world out there. But there's just less of it once we get into mafic rocks. So it's not like there's no silica. There's still silica. There's just less. Okay, so that's all I've got for this one. Yeah, let me know if you got any questions.